Cosmological information. Heredity, CIH, is the principle that global quantum information is conserved across cosmological phases and cycles, while the effective physical laws governing each phase may change. In this framework, successive cosmological epochs are not independent creations, nor exact repetitions, but descendants linked by informational continuity. Formally, CIH separates information inheritance, conserved, law inheritance, contingent, and emergent. This principle is central to Defreeze cosmology, as proposed by Mohammed Hassan Al-Ghuri. CIH implies that the universe does not restart, the universe does not forget, the universe does not repeat. Instead, it inherits, transforms, and re-expresses its information under evolving physical realizations. Cosmological information heredity formalizes the idea that successive cosmological epochs are linked by conserved quantum information, but differentiated by emergent physical laws, allowing continuity without repetition and novelty without creation. Law plasticity refers to the capacity of effective physical laws to change across cosmological epochs, while global quantum information remains conserved. Within Defreeze cosmology, this principle formalizes the separation between informational continuity and dynamical or symmetry continuity. The former is fundamental, the latter is emergent and contingent. This subsection articulates how conserved information can be re-expressed under different effective laws following cosmological phase transitions, freeze, defreeze, contraction, bounce, without violating unitarity or thermodynamics. Mechanisms enabling plasticity. Several generic mechanisms allow law plasticity without information loss. 1. Symmetry restoration and rebreaking. During contraction and near-bounce regimes, effective symmetries may be restored. Post-bounce cooling selects new symmetry breaking patterns, yielding different low-energy realizations. 1. Vacuum basin selection. The Defreeze transition reorganizes vacuum correlations. The post-bounce vacuum may settle into a different basin of the theory's landscape, altering constants and spectra. 1. Accessibility reweighting. Using the accessibility functional AT, the same conserved information can become active in different sectors. These mechanisms operate without erasing correlations, only redistributing how they manifest. Predictive constraints. Law plasticity is not unconstrained arbitrariness. The following limits apply. Unitarity constraint. Global evolution remains unitary. Causality constraint. No acausal signaling across phases. Continuity constraint. Changes in L arise through phase transitions, not discontinuous resets. Consistency constraint. Post-bounce laws must admit stable macroscopic structures, compatible with the inherited informational substrate. Thus, plasticity operates within a bounded space of viable effective theories. Relation to cyclic and conformal models. Unlike exact cyclic models and conformal cyclic cosmology, which effectively projects away much micro-information, Defreeze cosmology maintains full informational heredity while allowing law-level novelty. This places law plasticity as a middle ground between repetition and erasure. Implications. Law plasticity under information conservation implies that successive universes are informationally continuous but physically novel. Cosmological evolution admits historical contingency at the level of laws. Fine-tuning problems can be reframed as outcomes of vacuum selection across epochs. In this sense, cosmology becomes evolutionary rather than repetitive, without abandoning fundamental conservation principles. Law plasticity under information conservation formalizes how a universe can preserve its complete quantum information across cosmological transitions while re-emerging with different effective laws, enabling continuity without repetition and novelty without information loss. Let's do an analogy with biological evolution, information heredity with law plasticity. In biology, genetic information is conserved across generations at the molecular level, DNA sequences, even though organisms differ radically in form and behavior. Formally, genome, conserved information carrier. Phenotype, emergent, environment-dependent expression. In Defreeze cosmology. Quantum microstate. R, conserved information carrier. Effective laws. L, emergent vacuum-dependent expression. Just as conservation of DNA does not imply conservation of phenotype, conservation of quantum information does not imply conservation of physical laws. Mutation, scrambling and defreeze dynamics. In biological systems, mutations rearrange genetic information. DNA is not erased, but recombined or reweighted. Small changes can produce large phenotypic effects. In Defreeze cosmology, scrambling during contraction and bounce redistributes correlations. Defreeze dynamics change which degrees of freedom become accessible. The same information yields different effective realizations. This plays the same structural role as mutation and recombination. Environment, vacuum structure. In biology, the environment determines which genes are expressed. Identical genomes yield different phenotypes in different contexts. In Defreeze cosmology, the vacuum state determines which correlations become dynamical. Identical informational substrates yield different laws under different vacuum basins. Selection, vacuum stability, and consistency. Natural selection does not preserve all phenotypes, only those compatible with survival and reproduction. Similarly, in Defreeze cosmology, not all law realizations are dynamically stable. Only vacuum configurations supporting coherent macroscopic evolution persist. Law plasticity is constrained by consistency, causality, and unitarity. No repetition, no reset. Biological evolution does not repeat exact organisms, even with conserved genomes. Lineages persist, but outcomes differ. Likewise, cosmological epochs are informationally descended, not repeated. There is no reset of the universe. There is no return to identical laws. This rejects exact cyclic cosmology, law reset by fiat, while preserving continuity. Defreeze cosmology exhibits a form of cosmological evolution, structurally analogous to biological evolution. Global information is conserved, while its expression as effective laws varies across epochs under vacuum-dependent constraints. The universe thus evolves informationally without repetition or erasure. Cosmological information. Heredity, CIH, is the principle that global quantum information is conserved across cosmological phases and cycles.